3.2 is about properties of parallel lines. First one they talk about is same side interior angle postulate. Okay, so if we have two parallel lines cut by a transversal, this line that cuts parallel lines is called a transversal. We have the same thing where angles on the same side are equal to 180 degrees. So 4 plus 5 are 180 degrees. So angle 3 is 55 degrees. So this one right there, 55 degrees. Which angles are supplementary to angle 3? Okay, well, again, it's which one it is. So supplementary is equal to 180 degrees. So any lines, or any angles, I'm sorry, that form a line with angle 3 would be supplementary. So angle 4 and angle 2, because they're what we call linear pairs. Okay, well, what else? Well, angle 8 would be, right, because of same side interior. Okay, because they're on the same side of the transversal. And then angle 6 would be because it's vertical to angle 8. So those are congruent, therefore they're going to be supplementary. 3.1, again, we're talking about parallel lines cut by a transversal. We have alternate interior angles. So that would be 4 and 6 are congruent, and then 3 and 5 are congruent. Okay, that's 3.1. 3.2 talks about corresponding angles. So same thing, parallel lines cut by a transversal, corresponding. Corresponding means same side of the transversal, but opposite sides of the line. So angle 3 right here is going to angle 7. Those are what we call corresponding. Notice how they're on the same side of the transversal, but this one's actually they're on the same side technically of the parallel lines too. Angle 3 is underneath, angle 7 is underneath the parallel lines. We have angle 1 here, just as another example, above on the left side of the transversal and above. Well, what's on the left side and above? Well, angle 5 as well. And then you can see, again, 2 to 6 and 4 to 8 by the same thing. Last one is alternate exterior angles. So again, alternating are congruent. So angle 1 is on the exterior, angle 7 is on the exterior. Those are congruent. Problem 3 talks about what are the measures of angle 3 and angle 4. They give you this angle down here is 105 degrees. They want to know what angle 3 and angle 4 are. Well, if I look at angle 3, what do I notice? Those are what we like to call alternate exterior angles. So, I'm sorry, alternate interior angles, I apologize. Angle 3 is going to also be 105 degrees. Angle 4 is right here, so those are, if we look at this line with that transversal with these two parallel lines, they're on the same side interior. So angle 4 plus 105 equals 180 degrees. If I subtract 105, angle 4 equals 75 degrees. In problem 4 now, we're still using the same stuff. What is the value of angle y? Well, y is this part of that whole angle. Well, this whole angle plus the 80 degrees is going to equal that. So if I take that angle, which is y plus 40, plus that 80, that's going to be 180 degrees because they're same side interior, which would make them supplementary. I'm going to subtract the 80 over. I get y plus 40 equals 100. Subtract the 40, I get y equals 60 degrees. Part B, again, let's take a look. We got parallel lines cut by a transversal. I know it looks like a figure, looks like a trapezoid, but it's the same principle. We got parallel lines cut by a transversal. So 2x plus x minus 12 equals 180. Add like terms, I get 3x minus 12 equals 180. Add the 12 over, I get 3x equals 192. Divide by 3. And I get x to be 64. Same thing on the other side. 3y plus 20 equals 180. I get 3y plus 4y is, or I'm sorry, 3y plus y is 4y plus 20 equals 180. Again, subtract 20. I get 4y equals 160. Divide by 4. I get y equals 40.